Alright, hello everyone. In this video I'm going to talk about the market model, which I was planning to cover at the live lecture today, but couldn't do that because of limited time. Let me address this topic in this lecture video. The market model was introduced as the key application of linear algebra to economics in the textbook. I can't skip this model because it is very important. I believe in the previous video I presented the basic idea of this model. Just a reminder of what is described by this model. There are two markets, okay? And in market one, good one is traded between buyers and sellers, and in market two, good two is traded, okay? And we have 6 variables in this model: demand for good one and for good two, and supply of good one and good two, and the price of each good, P1 and P2. Okay, and then there are a bunch of parameters. We have 3 parameters in the demand for good one, and another 3 in the demand for good two, and 2 B's in supply of good one, and 2 D's in supply of good two. Okay, and let me assume that all the parameters are strictly positive. Okay. So with that in mind, if we take a look at the demand for good one, okay, and the coefficient of P1 is given by some negative constant. Okay, that means if price 1 goes up, okay, then the demand for that good goes down. Okay, we usually call that the law of demand. Okay, if the price of one good increases, then people tend to consume the other good. So as a result, the demand for that good decreases. Okay. So due to this negative sign, we can see that the law of demand holds in market one. Okay. And similarly, the law of demand for the second good also holds, because due to this negative sign. Okay. But if we take a look at the coefficient of P2 in demand for good one, it is given by some positive constant. Okay. That means if the price of the other good goes up, then demand for the good goes up as well. Okay, so they move in the same direction. So we can observe this kind of situation when 2 goods are substitutes, just like a Coca-Cola and Sprite, and iPhones and other Android phones, for example, Huawei's phone or Samsung Galaxy. Okay. The basic idea of this co-movement is if the price of the second good goes up, for example, if the price of the Sprite goes up, then some Sprite consumers may switch to Coca-Cola, thereby increasing demand for Coca-Cola. Okay? And a similar relationship holds in the demand for good two. If the price of a good one increases, demand for good two also increases. Okay? So we can see the same substitutability assumption holds in the expression of demand for good one and good two. Okay, and while the demand depends on the two prices, supply is assumed to be dependent upon just the price of itself. Okay? So the supply of a good one is a function of P1 only, and supply of good two is a function of P2 only. Okay? So it is independent of P1, and supply of good one is independent of P2. Okay? So in this model, what I'm going to do, because every variable, so every economic force, supply and demand is given by linear equation. Okay? So we can adopt the previous tools, linear algebra tool we studied so far, to make a prediction in this market model. Okay, more precisely, we can start with the equilibrium condition. At the equilibrium, 2 economic forces are exactly offset. So at the equilibrium price, demand for good one is exactly equal to supply of a good one, and the demand for a good two is exactly equal to supply of a good two. Okay, so the 2 economic forces, supply and demand, are exactly balanced out. So if we write the equilibrium condition here, so at equilibrium, we must have QD1 equal to QS1, yeah, and and QD2 should be equal to QS2. Yeah. And then I can rewrite the first condition in terms of P1 and P2. So just by substituting this expression, A0 minus A1 P1 plus A2 P2 is equal to B0 plus B1 P1. Okay, and let me take P terms and collect them on the left. Okay, and then take the other terms on the right. Yeah, and after arranging this equation this way, then I'm gonna have negative A1 minus B1 times P1 plus A2 P2. Okay, so I collect P terms on the left and the other terms on the right, B0 minus A0. Okay, and similarly, if I rewrite this condition in terms of P1 and P2, equal to D0 plus D1 P2, okay, and I have C1 P1 plus negative C2 minus D1 P2, factoring out P2, then D0 minus C0 on the right. Okay, so the two equilibrium conditions can be summarized by these two linear equations. So this guy and this guy. Okay, so we come up with a pair of linear equations, and they are linear with respect to P1 and P2, so we can merge them into the one single equation in the matrix form. Okay, and the coefficient matrix is going to be negative A1 minus B1 and A2 in the first row, and C1 and negative C2 minus D1 in the second row. Okay, and we have two variables P1 and P2, and on the right we have two constants. Okay, so after arranging into the matrix form, we are going to have this matrix equation. Okay, so what I'm going to do with this equation, so let me call this 2 by 2 coefficient matrix matrix Q. Yeah, and if matrix Q is invertible, then I can pre-multiply by Q inverse here and Q inverse here. Yeah, then the product of these two boils down to identity matrix. I'm gonna left with just the P1 and P2 on the left, and on the right the product of these two. Okay, and we know how to compute the product of the two matrices. So in the end, we can find the equilibrium price of P1 and P2 in a general form. Okay, that's what I'm gonna do. But before doing that, I have to make sure that this matrix Q is invertible. Okay, and we studied several equivalent conditions for invertibility, and we know when one matrix is invertible if that matrix has full rank, or the determinant of a matrix is non-zero number. Okay, because the given matrix is a 2 by 2, and we have a simple formula for the determinant of 2 by 2. So let me use the second criterion. So I'm going to use the determinant of this matrix Q to figure out under which condition this matrix is invertible. Okay? So determinant of Q can be written by negative A1 minus B1 times negative C2 minus D1. Okay? So the product of two diagonals, and I have to take away the product of the off diagonals. So minus A2 times C1. Okay? and I have a negative sign in this parenthesis and in this parenthesis as well. So those are cancelled with each other, so everything will be positive. And so if this determinant is a non-zero number, then I can say Q is invertible. Yeah, actually this is an equivalent statement. So Q becomes invertible if and only if determinant of Q is a non-zero number. Okay? In other words, if the product of these two is not equal to A2 times C1, then we can say Q is invertible. Okay? So the equilibrium price in the end can be computed by the product of these two. Okay, so before proceeding, if we think about the economic interpretation of these conditions, so under which conditions on the market we have different products. Okay? And so if we go back to the model, we have in this condition we have A1 plus B1. Okay? And let me go back to the model. What is A1? So A1 is right here, okay, given by the coefficient of P1 in demand for good one. In demand for good one. Yeah. If we think about the interpretation of this A1, so if A1 is really large, that means even if the price of a good one changes a little bit, the demand for that good changes a lot. Okay? So A1 measures the sensitivity of demand with respect to change in price of a good one. Okay? So we usually call that demand elasticity of good one. Okay? Price elasticity of a good one. Okay? So A1 is related to price elasticity of demand for a good one. Okay, and similarly C2 in the expression for demand for good 2 is related to price elasticity of demand for good 2. Okay, if C2 gets larger and larger, we can say demand is very sensitive to change in price. Okay, and A2, however, okay, we have a A2 on the right. A2 measures the degree of sensitivity of demand with respect to change in price of the other good. Yeah? Change in the price of the other good. Yeah? So if A1 is larger than A2, because B1 is given by some positive constant, then we can say A1 plus B1 will be larger than A2. Okay? So, if A1 is larger than A2, then A1 plus B1 will be larger than A2. Okay? And similarly, if we compare C2 plus D1 and C1, D1 is given by some positive constant. Okay? So disregarding D1 for a second, if C2 is larger than C1, okay, then clearly C2 plus D1 will be larger than C1. Okay? So as a result, the product of these two, A1 plus B1 times C2 plus D1, will be way larger than A2 times C1. So this condition is met. Okay? Once again, the interpretation is the interpretation of this guy, this inequality. If in market 2, if the demand is more sensitive to changing the price of its own commodity, yeah? So demand for good 2 is more sensitive to change in P2 rather than change in P1. Yeah? Then C2 is larger than C1. Yeah? So put simply, we can say if each market is more sensitive to change in its own commodity price, yeah? So QD1 is more sensitive to P1 rather than P2, and QD2 is more sensitive to P2 rather than P1. Yeah? Then this equation holds. This condition holds. Okay, so Q is going to be invertible. All right, and then so we are going to look for the equilibrium price of a market 1 only. Yeah? We examine P1 star. Yeah? So, in this case, so when we look for some particular variable other than, rather than the entire vector, we can rely on Cramer's rule to find out the equilibrium price in an easier way. Yeah? So by Cramer's rule, we can write the P1 star as 1 over determinant of Q times the determinant of this 2 by 2 matrix. Okay, so in this matrix we have the first column, this guy, okay, and second column is from the matrix Q. Okay, so A2 minus C2 minus D1. So we leave the second column in Q alone, okay, and replace the first column with this one, B0 minus A0, D0 minus C0. Okay? And the determinant of Q is right here. And the determinant of this 2 by 2 matrix is right here. Okay? So the product of these two minus product of these two. All right, so that is the equilibrium price of a good one in this linear model. It's slightly complicated, but I want to do some economic analysis using this formula. Yeah? More specifically, I want to consider the following situation. Central government is considering to impose a sales tax on price of a good one. Okay? But this tax is imposed on the supplier side, not the consumer side. Okay? So sales tax on each commodity one produced. Okay? So here is one specific example describing this situation. So commodity one is the plastic. Okay? So the central authority might want to reduce the usage of plastic for environmental concerns. So it wants to impose some sales tax. Okay, so if tax is levied, what kind of change we can also what kind of change is induced by such a tax? Yeah, remember, tax is imposed on supplier side. Okay, so it will make some change in the supply of a good one. Okay, and going back to supply equation, QS1 equals B0 plus B1 times P1. Okay? And if we read this supply equation, it means if the unit price is given by P1, okay, so the good one per unit is sold at price of P1, then this amount of quantity is supplied to the market. Okay, so suppliers are willing to supply this amount of quantity, okay, this amount of quantity to the market. All right, but if tax is levied, okay, so for each sale, supplier has to pay amount of T to the government. Then it changes the unit price. So it does not change the unit price, but it changes the revenue per unit from P1 to P1 minus T. Okay, for each sale, supplier can earn as much as P1. Okay, but now they have to pay a part of that in the name of tax as much as T. Okay? It decreases the revenue per unit to P1 minus T. Okay? So with that interpretation, we can see that after tax, supply curve will change to B0 plus B1 times P1 minus T. Okay, so B0 minus B1T plus B1 P1. Okay, so after rewriting the the supply equation, I can see that the slope of the curve is the same as before. Okay, there is no change in the slope. Okay, just y-intercept goes down by b1 times t. Okay, so remember in economics, we somehow put the price on the vertical axis and the quantity demanded or supplied on the horizontal axis. Okay, so these two equations, so these two functions are kind of inverse functions. Okay, because we put the x component on in the place of y, okay, and the x or y component in the place of x. Okay, so although we are given this equation, this function, in order to graph this function on this p and q or q and p coordinate, we have to solve this equation for p. Okay, so if we solve this equation for p or p1, then p1 is going to be b0 minus b1t divided by b1, minus and plus. Okay, and qs1 over b1. Okay, so it looks like this. It is a still linear equation, yeah, but the slope of this line is going to be 1 over b1, not equal to b, or not equal to b1, because this is, once again, this is an inverse function. Yeah, and it seems like it seems that y-intercept goes down. Actually, we can see that after rewriting this equation in the right form, in the regular function, we can see that y-intercept goes up by t, because we have this additional term after tax, b1t, divided by b1. So supply function will go up as much as t, the tax rate. Okay? So the tax will shift here. So tax imposed on the supply side will shift the supply curve by t. Okay, so it's going to be vertical translate. Okay? And the slope of the curve is the same as before. The only difference is now it shifts upward by t, as much as the tax rate. Okay, so with that, because there is no change in the demand. Okay, so this is a QD1, and the original supply curve is QS1, but after tax, it will shift up by T. Let me call that QS1 prime. And the equilibrium price is determined at the intersection between supply and demand. So the previous equilibrium price was right here. Okay, and I can see that after tax, price will increase by this amount. Okay, so there will be some increase in price. But this is not the only thing we can say from this model. Yeah, because this is a partial equilibrium analysis. When you analyze the equilibrium, so when you compare these two equilibrium, we didn't consider the impact of change in price in the market too, because as I told you, demand for good one has some relationship, has some impact on P2. Oh, the other way, the price of P2 has some impact on demand for good one. Yeah, and similarly, if P1 changes like this, it will impact on demand for good two. Okay, so if we consider this kind of general equilibrium effect, okay, meaning that we take into account the interaction between market 1 and market 2. Okay, so I can anticipate there will be some increase in price in market 1. Okay? There will be some increase in price of a good one. Okay? Then how does it affect market 2? How does it affect in market 2? So let me draw another XY plane. So this is a quantity demanded in market 1. This is a quantity demanded or supplied in market 1. And this is a price of a good one. And P2 and Q sub 2. Okay, and then there is a no change in supply and demand even after tax. But okay, so in principle, because the only thing changes after tax is the B0. So let me go back to the slide. If the central authority imposes tax, then B1 P1 becomes B1 times P1 minus T. Okay, so in the end, the supply curve of a good one is going to be, originally it is given by this one, but changes to B0 minus B1T plus B1 times P1. Okay. And yeah, there is a typo in the second bullet point, but you may disregard this phrase. Determinant increases with B1 because there is a no change in B1. As a matter of fact, what changes is the this y-intercept. The y-intercept of the supply curve changes to B0 minus B1T. Okay, that means this B0 that only appears in this bracket. So B0 goes down after tax. Okay, so because we have a negative sign in front, if the size of B0 goes down, we can see that P1 will go up. Okay, will go up. That is what we can see from this figure. After tax, okay, because tax will shift up, so tax will shift the supply curve upward by T. So equilibrium price of a good one will increase. Okay, but we want to see the general equilibrium effect. Yeah? So how does it affect market 2? Okay, because if the price goes up in market 1, we can anticipate demand also responds. Okay, and demand responds downward. So because price goes up, then people will shift to market 2. iPhone users will switch to Galaxy. So demand for that good will reduce down. QD1 prime. Okay? And then that will affect demand for good 2. That will go up. Okay? So we can see that price of good 2 also increases. So depending on the reduction of the demand, if the demand shifts a lot, so if the demand changes a lot, like this, okay, then now the new intersection between the supply curve and demand curve occurs here. Yeah, it seems like there is not much change in the equilibrium price of a good one. Yeah, after considering this general equilibrium effect, I mean after considering the interaction between market 1 and 2. Okay, so now we have to consider how much reduction we can anticipate in the demand side due to this tax. Okay, and the last bullet point explains this size of effect. So that is related to sensitivity of price, the sensitivity of demand and supply in market 2. Yeah, I mean C2. Okay, so the price sensitivity of demand with respect to P2, that is measured by C2. If C2 is large, okay, which means the people responds very sensitively. So people responds very sharply with respect to change in price of a good 2. Change in price of a good 2. Okay, so if C2 is a very large number, if we have a small reduction in B0, then P1 star the increment of P1 will be large. Okay, I mean, if C2 is a large number, okay, then we can anticipate reduction of B0 after tax. Okay, so then increment of P1 will be large. Okay? But if C2 is a small number, very small number, and even if you have a reduction of in B0, increment in P1, so the impact on the price of a good one will be very small. It will go up, but the size of increment, so the magnitude of increment will be very small. Okay, now we can think about the intuition behind that. What is the economic intuition behind this result? Let me take some specific example. Okay, because I started with the interpretation of good one as a plastic. So good one is a plastic cup, and good two is a recyclable, say cups, say tumbler. Okay, so you go to Starbucks to order a cup of coffee with a plastic cup. Okay, and you realize that price goes up by 50 cents. Okay, you're asked to pay 50 cents more. Okay, then the clock says due to environmental tax, they have to impose additional 50 cents on the on every use of a plastic cup, for example. Okay, then you may look for a tumbler instead of using this plastic cup, but tumbler price also goes up by $10, for example. And if you are very sensitive to change in price of the tumbler, then you may be reluctant to purchase the tumbler. Yeah, so the price of a tumbler goes up by $10, but you can use that. You can continue. You can keep using that tumbler once you buy that. So we are not comparing the 50 cents and $10, but just to imagine that how much sensitive you are changing price in the change in price of a tumbler. Yeah, and if you are very sensitive, you are reluctant to purchase this tumbler, meaning that you are reluctant to switch from market 1 to market 2. In the end, the reduction of this demand due to tax will be small. Okay, so the equilibrium price is that occurs at this intersection. But if you are not reluctant to the change in price of a tumbler, even if it increases by $10, you are still willing to purchase that, and you will switch to the use of a plastic cup to the use of a tumbler. So the reduction in demand will be large. Okay, so the price of a good one still increases, but the increment of price will be small. Okay, that's what I want to say through this last bullet point. Okay, so the last bullet point is slightly difficult to understand. So if you have trouble with understanding this last bullet point, feel free to ask me at the live lecture next Friday. Okay? So hope you find this video useful, and I see you in the next video.